Welcome to another Arduino programming tutorial. In this video, we'll be talking through the code and the hardware needed to create what I would refer to as a soft emergency stop scenario. It's not a hard emergency stop. What I would associate with a hard emergency stop is that a person has a button, a push-on, push-off style button that's wired in series with one of the power or ground lines going to the Arduino. So when you slam down on that button, it manually disconnects all the power going to the Arduino, and as long as your button, the internal mechanism of your button holds together, you know that the Arduino is doing nothing. Conversely, in this case, our Arduino, the power will not be cut to it, but it will, for all rights and purposes, will have stopped doing anything when we press a particular button. So it'll be a soft emergency stop. The Arduino still has power, but it shouldn't do anything as long as the register values, there's no snafu, there's no power surges with the power supply to the Arduino. For all intents and purposes, the Arduino will have stopped and will not restart whatever code we wanted to run before the emergency stop. It won't do that again until we press the external reset button on the Arduino board itself. So first thing we need is the circuitry needed to make this code work. Let's look at that.
To build the circuit, we'll need a momentary button, a normally open momentary button, meaning that the bottom two legs are not connected to the top two legs until the button is pressed. You press it and it creates continuity between top pin, bottom pin. A 10K resistor and some wire, breadboard. I'm just using Arduino Uno. Let's zoom in. All we need to do is put our momentary button in the breadboard. We straddle the center rails. We take our 10K resistor, hook it in the same row as the top leg of our momentary button. One leg of the resistor, the other one is in the ground rail. Then we need a piece of wire from the bottom leg of our button to the power rail on the breadboard. Bottom leg of button, power rail on breadboard. Then we will need a piece of wire in the same row as the resistor leg and the top button leg. Connect that to digital pin 2 on the Arduino that is associated with interrupt 0. And the way this setup will work as soon as we connect these other pieces of wire is digital pin 2 will be receiving a low signal due to this pull down resistor all the time until we push the button, which will send the 5 volts through the button, across the contact, up through this wire to digital pin 2. Then we're triggering our interrupt off of a rising edge. So when that button is pushed, the voltage rises and is translated to digital pin 2, where we'll have our interrupt code listening to what the state of that pin is. It's low constantly until we press the button, then it rises up to 5 volts. And this resistor and pull down configuration ensures that, yes, in fact, the pin is not floating, it is pulled down to ground while the button's not pushed. To make this work with the breadboard, we just need one more wire connected to 5 volts on the Arduino, going to the red power rail from 5 volts to the red power rail, then second wire into ground, one of the ground pins of the Arduino, to our ground rail. And that's all we need. Let's go back to the code.
With our circuit in place, we can start talking through the code. Notice that the pins that are used in this code is just going to be digital pin 2, which will be associated with an interrupt 0 on the Arduino Uno. There's quite a few good videos that explain the interrupt system on the Arduino. What we'll be doing is what's known as an external or a hardware interrupt. We'll be making use of that feature of the Arduino and the Atmega 328 chip on the Arduino. It's got built in on digital pins 2 and on digital pin 3 interrupts. Interrupt 0 corresponds to digital pin 2. Interrupt 1 corresponds to digital pin 3. We'll pick digital pin 2 because it doesn't have the ability to generate pulse width modulation innately, and we may need that for something else depending on what project a person is wanting to use this soft emergency stop code in. So we got digital pin 2. That's all we're using. We've seen how the circuitry goes with it. We have our Arduino plugged in to our computer. So we got that taken care of. The hardware, like we've seen, is normally a momentary button and a 10K pull down resistor and some wire. That's all we need. Now, what is this program going to do? Well, it'll run whatever code we want it to run until that interrupt 0 is triggered. And in turn, by a push of our momentary button, it'll trigger interrupt 0, and then that interrupt will trigger a void loop stop. If you haven't already checked it out, it would be helpful before continuing with this video to look at my video on how to stop void loop and the code associated with doing that. This particular video assumes you're familiar with how to stop void loop. If you're not, definitely check out my video on how to stop void loop. It'll put you that much further along in the understanding game. Now, there is a caution that needs to be mentioned up front, that this is not what I mentioned as a hard emergency stop where you have a button, a push on push off style button like on amusement park rides or an industrial machine, where you slam the button down and it stays down until you twist it 90 degrees for it to pop back up. But you slam that button down, it stops, it cuts the power to the Arduino. That would be a hard emergency stop, a non-software dependent emergency stop. Whereas this is a soft emergency stop, hence soft emergency stop program. And it's not as safe a mechanism of stopping what the Arduino is doing as that hard stop would be. Just keep that in mind. And so it should never be used or relied upon in like a supercritical application like stopping an automobile, a motorcycle, some vehicle. You shouldn't use the Arduino in the running of such machines anyway. Even the Atmega company doesn't ensure they're chipped to that effect. So the Arduino doesn't need to be in those applications or medical, life-saving, industrial machines. The way to think about it is, could someone lose a finger or an eye like on a battle bot or something? Or a car or a medical application? Could somebody be hurt really bad? If so, you don't use this code for that. You use a hard emergency stop set up with a manual button that cuts the power to the Arduino itself. This is more for cases where we have like a little small floor sweeper robot or something that's running across the floor, and we want it to have like bump buttons out front or bump switches, so that if our ultrasonic sensor that's pinging back and forth from the wall to the Arduino, say that there's a curtain in the way and the ping doesn't come back in enough time to stop our robot before it plows through the curtain into the wall. Well, if that were to happen, you could have this setup, this soft emergency stop set up with the momentary button hanging out front of your little robot. So when it bumps into the wall, it hits that momentary button, triggers this code, it stops everything, or stops void loop at the top of void loop so it doesn't go through a cycle again. Then you could go back, pick your robot up, push the external reset button on the Arduino, and start it all over again. But it won't come back on until you reset. Push the reset button, not the button connected to digital pin 2, but the actual reset button on the Arduino. Some people have an application for these soft emergency stops, and one of the viewers asked for me to do a video about this. That's why we have this video. And then it is a useful thing if you have, like, say, a simple little model Ferris wheel, model roller coasters, whatever, with an Arduino, just a sort of model small scale thing. Sometimes it's really nice to have the soft emergency stop program running in concert with all your other code, so that you can just push a button and the Arduino will stop whatever it's doing, so you can move stuff around, make sure, get your parts arranged, whatever. That's what it's useful for. But it's not for any automotive, medical, industrial machines. It is not good for that. If you could lose a finger or an eye, this is not the code for you. Okay, the cautionary tale has been told. Now, what is the first thing we need to do in our software? We've got our Arduino connected, so we can open up the IDE, and we need two global variables. The first one is a Boolean type. It's just named start, and we're going to assign it the value of true. This will work with our stop void loop code that we'll see inside the void loop function. The next variable we'll need is a volatile. We need to qualify it as volatile. It'll be a Boolean type. I've just named it eStop, just so simple, easy to remember, and I've assigned it the value of false. This will be the variable that gets toggled during our interrupt service routine function that we'll look at down at the bottom of the code. But it needs to be volatile. Anytime you're using one of these hardware or external interrupts, you want the variable that'll be toggled inside RAM, so the Arduino has it right in hand rather than just stored in one of its registers somewhere. So you'll definitely want to qualify it as volatile. In void setup, we just have void setup. I'm going to use a serial based example, so I have the serial monitor. If you have LEDs or servos or whatever, you would need to declare their pin modes here, but for our purposes we have serial begin, set it at 9600 baud, brief delay to give that serial connection enough time to establish. Then we move into the actual interrupt code. This is one of the inbuilt functions in the Arduino, like delay or whatever. It's attach and interrupt. And this is one of the things that can be a little confusing about this function, but it takes the interrupt number associated with those digital pins, digital pin 2 or 3, rather than the pin number itself. Notice we don't have a variable for digital pin 2, nor are we declaring its pin mode. Rather, all of that is taken care of by this attached interrupt function behind the scenes when we just associate 0 with the first parameter of this function. This is basically saying listen to digital pin 2 for a change of its state. Remember, we have it pulled low by that 10K pull down resistor, so it's going to be listening to digital pin 2. And what it's listening for is a rising state. It's listening for the moment when it's running on logic level 0, the button is pushed, it shoots up, it rises on the rising edge to 5 volts. That's what this will pay attention to and register when that happens immediately. This isn't like polling a pin. It is polling digital pin 2, just like if you were doing a digital read on it, but it's doing it at a much more fundamental level as far as the Atmega chip goes. It's running behind the scenes. And so on that rising edge, it'll trigger this interrupt. Anything that's currently going on in the code will stop. It'll save its play, save whatever variables it was using, save their values. Then it'll immediately execute that function, this eStop ISR. That is the name of a function that's down at the bottom of the code. So that's how it works. A call to that IRS function when digital pin 2 is switched from low to high. It's normally low due to the pull-up resistor attached to the external button that we've added. That's what that line of code is doing. That's the end of void setup. And what does this function look like? It's down here at the bottom underneath void loop. And here it is, the interrupt service routine function. All that it does is as soon as it picks up a rising edge when the button is pushed, it immediately detaches the interrupt that we've associated with digital pin 2. This is a sort of coding wizardry trick to keep us from having to do a whole lot of external debouncing. There is a way to externally debounce digital pin 2, and it's perfectly fine. There's videos on that already on YouTube, or I can create one if people are interested using a Smith trigger setup. But as far as doing a soft emergency stop, given that we're not going to be using this in a dangerous situation anyway, well, all we need is to catch the rising edge, cut the interrupt off, which means on digital pin 2, which means that it stops paying attention. It doesn't listen to what's going on digital pin 2 anymore. So if there's noise when our button bounces, it's really not going to pick it up. I mean, the only noise that it can pick up is the time it takes for that button to be pressed and to execute the function, which is in microseconds, or some maybe even beneath microseconds. It's super fast. Could a little bounce go through here? Maybe, but not much. Not enough to really be overly concerned about by just detaching and quit listening to the pin as soon as the rising edge is detected. That's what detach interrupt does. And we do that as soon as it enters a function. Then right after that, we toggle the value of our eStop variable. It's initially going to be set to false, so we're going to toggle it to true at that point. Then what will happen is it'll go back to the top of void loop at that point. So what's happening in void loop is, as soon as we enter void loop, we want to test. We want to say, what is the value of the start variable? Is it true? Well, when we initially run this code, it will be true. So it'll pass the test, the first run through. Then it's immediately going to do another test. Well, is the value of the eStop variable false? The first time through, it will be. That has the effect of making whatever code that's running in here run. And all we're going to have it do is serial print line, all is well with the world. This is where, and then delay for 300 milliseconds, and then print all is well with the world again. What will happen is this condition will come out, it'll pass that, then it'll hit this one, it'll pass on the first time through, and it'll execute whatever's underneath this eStop test condition. This is where I'm using a serial example, but this is where to locate code want to run all the time. This is where you want to locate whatever your code is. If you're changing LED, turning LEDs on and off, running little servo motors, running a robot, this is the location of that code. The code you want to run continuously until an emergency stop event occurs. And then if we do push the button and the interrupt service routine is called, we want it to go to this else and say print emergency stop and must press reset button to restart the program. And then we basically toggle the value of start. It's initially true. We set that up there, and above setup, we turn it to false. And what that'll do is the next time through the loop, after the interrupt has occurred, it will go to the else, the start value will be toggled to false, and then when the code rotates around back through void loop, it'll test start again, start will be false, so void loop halts. It doesn't halt in the sense of stop doing anything. It never does. Void loop will be running because the Arduino still got power. Remember that. This is a soft emergency stop. It's not power disconnect style emergency stop. That the Arduino will just keep checking the value of the start variable. It'll say, is start true? Well, no, because we set it to false, and it's just going to spin itself eternally right at this point and never move past this line, as long as there's no power surge and the power going to the Arduino and something happens with this value of false that we've stored in the register down here. That's why you wouldn't want to put this on a life critical application or something where you know there's danger associated with it, because there could be a surge in your power line, could toggle this or restart the Arduino, and if that happens, it's going to pass and it's going to be running that same code again. So if you got it hooked to something, you know, that you don't want to lose an eye or a finger with, it could happen if there's a surge in your power line. So this is good for, like I said, little robots, things that are not going to hurt anybody, and it will work every time. And that's all there is to it. So let's run through a scenario just to make sure that we understand what's going on. Initially, start will be set to true, eStop will be set to false. That means that when void loop reaches this point, it starts up, it's true, so it'll pass that conditional. eStop set to false, it'll pass this conditional, it'll run whatever code is in here. Until we push our button, the value, the interrupt routine's listening to what the state is on digital pin 2. As soon as it's on logic low, because the pull down resistor, as soon as we push the button, it rises up to 5. And on that rising edge of the wave, it'll trigger our eStop ISR subroutine, which is going to detach the interrupt immediately so it's not listening to any button bounce. Then it's going to toggle the value of eStop from false to true. Then we'll go back to the program will take it back to the top of void loop. It'll pass the start condition, but when it hits e-stop will now be true, so it'll fail this condition and drop down to the else, where it will print this or do whatever you need it to do at this point. Disconnect just set all the digital pins to low or whatever it is you want it to do. And then it toggles the value of start, which was true initially, to false. Then it hits the bottom of void loop, goes back up, start is false, and it halts right there. To see how that works, we can upload the code to the Arduino, turn on the serial monitor, and all is well with the world, given the way what we initially set our variable values to. All is well with the world. Then we can push our momentary button. I just pushed it. We got emergency stop. Must press the reset button on the Arduino board to restart the program. This Arduino will do nothing until the external reset button on the Arduino is pushed. We can push it. I just pushed reset. It takes it a second to restart from the top. That means it cleared out the changed values that occur with the interrupt. Now it's doing all is well with the world. This could be your robot running around, avoiding obstacles, following a line, whatever. Then we push our momentary button to our interrupt. We push the button. Emergency stop. Must press reset button to restart the program. And this will work every time as long as there is no push the reset. Now we're back again running. But you'll have to manually push the reset button for it to start back over. And this is the epitome of how a soft emergency stop code works. So that people who may need to, they can copy the code. There's your global variables. Just pause the video. You can type it into your IDE. There's setup. There's a void loop. And there's the interrupt service routine function. Hope this video has been helpful. Definitely let me know in the comments if there are any questions. We've done it kind of quick. The assumption is that the interrupt system, regardless if you understand perfectly how the external interrupts work, you can use this code to create a soft emergency stop program. Just always keep in mind that it's not for dangerous machinery that you might have built or whatever like that. It's for little simple things. It's a useful piece of code to have on hand at times. So if you like this video, please consider clicking like, and also consider checking out some of my other videos and subscribing to my channel. Until next time.